might just be StreamYard. Oh, hey. No, we're live. Great. I think we're live. So, oh, shit. Okay, let me just move because I think I'm sharing my screen now. One sec. This is great. Everything's super improvised at the moment.
We're live, so we can start. And apparently, I'm able to orchestrate the things. So yeah, let's start.
Yeah, cool. Welcome everyone. Welcome to another meetup. We're trying to make all of the technology work. So I hope you can see us and hear us well. Yeah, welcome to another meetup. It's October already. I hope that everyone had a good summer and relaxed as much as they could. Of course, in this somewhat awkward year. But yeah, we're planning to host these meetups on a monthly basis. We'll introduce in just a minute who everyone here is. But first of all, happy to see you again, and give us just a minute to work out some of the streaming problems we're having. Hope they're all resolved now.
Right. Yeah. Thanks, Marek. Let me just run us through our usual slides real quick to introduce the event to people who might not know us yet, because it's been quite a while, as you said. So first of all, I think we all were very happy to welcome you back and speaking to you was Marek Kuczynski from AWS. I'm Leon. I work for a company named Container Solutions, and our technician of the day is Sarah, and she's also from AWS. So I guess I'm alone today now.
But in good company.
Anyways, yeah, I mean, I love being with you again on air. So I'm just going to run us real quick through the slides because we've started a little bit late. So yeah, welcome to ServerlessDays Amsterdam. The meetup edition of online meetup edition of this long year that feels like 10 to 20 years. And we are trying to establish a specific schedule on which we are going to have these meetups. So you can always keep that in mind. So we're trying to do meetups every first Wednesday of the month. So once a month, first Wednesday, write it down now, and then you will remember for the future. Serverless Days is a global event. So we used to have these little local conferences, events in all these places that you see those cute mascots in. But nowadays, we're doing everything online. So you can watch the Serverless Days virtual conference or the virtual Serverless Days meetup events all over the world. And just type in Serverless Days, you'll find something that will suit your needs. And yeah, you can also see our conference from this year on YouTube still. And I think all the meetups that we streamed, they're also on YouTube. So just type in Serverless Days Amsterdam. And here we are right in our agenda. So we're supposed to welcome you at 18:50. Anyway, the next speaker who will be joining us is Natalia, and she will be talking about how to get started with monitoring with Lambda functions and Datadog. So I think we can just start early with the talks, right? Or do we want to wait? I don't think we need to wait.
Yeah, we can start, I think. Yeah, I think I gave a lot of time for the introduction. Maybe it's a bit shorter for the agenda.
I can maybe make just one small comment to also help us a bit with organizations and buy us a little bit more time, right? No, so just wanted to also share that we're always looking for diverse speakers, right? Either established speakers, people that would maybe like to speak at our meetup at the for the first time. So if you have an idea or you would like to speak, you maybe want to speak at one of these meetups as well, please reach out to us. What's actually the best way to reach out to us? That's an open question. Should people DM us? Is there an email?
Oh, you know what?
Twitter?
Yeah. I remember there are more slides here, so it's actually the next thing. Oh, I'm so sorry. It's been so long. I forgot about the slides. So well, very good that you asked the question, Marek. There's a Discord channel. You can get there via the link or the QR code, and we are on there to have the discussion. And also you can ask questions to the speakers because they're usually there. And this is the other thing. There's a code of conduct that applies to all the chat rooms and the Discord, of course. Please keep that in mind when you interact. But then there's also, it's not on, I think I'm showing it in the last slide. Yes, so you can also get in touch with us on this email address, amsterdam@serverlessdays.io, or on the Twitter account, ServerlessDAMs. DMs, get it?
ServerlessDays, yeah, it's a thing.
Yeah. Right. So totally right that we're also always looking for speakers. And if you are a first-time speaker or a junior speaker, you can also just reach out to us and get some input on your idea. Like just make a suggestion. You want to speak about this topic, and any feedback or any help that we can provide, we're happy to, to help you out.
Fantastic. I think those were all the slides, right? Or do you have even more?
No, I'm sure that these are all the slides.
Great. So shall we invite Natalia on board?
Yes.
Yeah, I think so. Let's do it.
There you go. Hi.
Can you hear me?
Yes.
Yes, nice. I do remember the tip to unmute myself. Very important.
I wish I would follow my own advices as well, but unfortunately that's not the case.
No, it happens. Let me share my screen real quick.
Natalia, would you like to introduce yourself, or would you like us to introduce you?
I do have a slide to introduce myself, but if you want to do it, that's also fine.
All right.
I mean, yeah. No, go ahead. You introduce yourself. I think you know yourself best.
Hopefully. Okay. Hi, everyone. You want to say something?
I'm gonna remove us from the board, and you can go.
Yes, as I was saying, good evening. Welcome to our lovely chat about getting started with monitoring with Lambda functions in Datadog. The idea here is really to share our experience really trying out Lambda for the first time. We had a problem that we hope the solutions we found can help you somehow with your challenges. A little bit about myself. My name is Natalia Pipas. I work as a data engineer at this company called Vonk. And I've been doing Python development for almost 5 years now, a little bit of Scala in the last year, some Spark development as well. I am a big fan of soccer and taking naps. And I just realized that I should follow the chat here to make sure people still hear me, but I think we're good. I think the soccer and the taking naps thing might sum up my life at this point. But I want to start checking if we need to, some people might ask, why do we even need monitoring? So in case you still have that question, I want to invite you to think about a beach and to think about software development as a sandcastle that you build. You spend a lot of time building your sandcastle. You think about all the components, and when it's done, right? Nothing's going to change in your sandcastle. Nothing's going to break your sandcastle, right? The environment is perfect. Well, that's not really how it goes. Usually something does happen to your sandcastle, but also to your software. So that's why we need monitoring to make sure we're actually ahead of the problem. So hoping I convinced you that monitoring and alerting is important at this point. I do want to explain how the company I work for works, so we can also talk about the data that we have and then why we ended up choosing Lambda and Datadog to help with some of our monitoring. Basically, in Vonk, we have customers, and our customers are usually companies, and they think things like, we could really use a Scala developer. And so they go to our job marketing platform, and there they get recommended a bunch of channels where they can advertise their vacancies. And after they get these campaigns with these channels, they start asking, okay, I really want to know how my campaigns are doing. So we built something for them called Recruitment Analytics. And the easiest way for me to explain what it is to actually show you with a GIF. Basically, it's a bunch of dashboards with data on their campaigns or on their company, what's the traffic like that they're receiving. Basically, they put some snippets on their website so we can aggregate the data that we get to produce these reports. Most of that is not important for what I'm going to talk about, but just for context, I wanted to show you this. Our data. Our data relies mostly on events, which are not really well represented by this icon. I am aware. It's more like this. People click on campaigns. People interact with job description pages and other pages. People spend time on pages that we can track using page banks, for example. And we collect these interactions, and a third-party provider actually does the collection for us and then puts events on S3. That's how this part of the process works. We will then aggregate these events and produce those dashboards, but I want to focus on the collection here for a moment. And as any process, it's not perfect, like things happen to it. And well, what can happen? Basically, there can be a problem with the event collection. If there's a problem with the pipeline of the third-party provider, it's gonna break the process. It usually doesn't happen. They're quite reliable, but something might happen. But what really happens more often is that the customer has an issue with the snippets we ask them to place on their website to collect the events. And that issue brings us to Armand. Armand is actually our support guy. He doesn't look like that. I just got a random picture from Google Images. But Armand once asked, can we be alerted when a customer has a problem with their snippets? And that actually triggered us a little bit because we monitor our infrastructure. We monitor the performance of our services, but we weren't really monitoring that part of the collection of the events. And things can go wrong there. So we started brainstorming what we could do to go around this lack of monitoring. So we started thinking about our data. What do we know about it? Well, we know we have millions of events. I think the total is almost 1 billion now. These events, well, we get updates every few minutes. So like a few times per hour, we get new files in S3. And once we know these two things, we can also ask the proper questions for our monitoring. And two questions that we thought were relevant were how many events are we receiving and in which frequency are we getting these events. So by having the questions, we can now ask, is this a good case for Lambda functions? Like we know we like the idea of serverless, Lambda sounds nice, but is it really what we're looking for? So we went to their website to see what they promise. And the first thing that we see is scalability. So the function scales depending on the size of the workload, is what they say. Okay, that sounds interesting, could fit our use case. They also promise an interesting pricing method. So you pay for the time your function runs. So if it doesn't run, you also don't pay. So that's also interesting for our use case, given that we don't have a stream of data in this use case. We just have files being added to S3 a few times per hour. So sounds convenient for us. And they also promise consistent performance. So you configure your function and you should have quick, consistent response times. Okay, that sounds interesting for us. Sounds like something we can give a try. But before I jump into a little POC that we did, I want to explain some main concepts because I don't want to just throw concepts assuming people will know what I'm talking about. So when I say function, it's pretty much the biggest, the most important concept. In Lambda, it's the resource that you invoke to run your code. So you're going to write a function that's going to be invoked. And then you also have the concept of an event. So event is pretty much a JSON object. If you're working with Python, it's going to be a dictionary with some data that's going to be processed every time your function is invoked. Okay. In this example here, just put a random JSON object that I found on their website that has temperature, humidity information, but it could be anything. It really depends on the data that you have. Okay, so another concept that I thought was relevant was the concept of a trigger. And this one, we're going to go a bit more in depth in a bit. But basically, you want your function to be triggered by something. So the trigger is the resource or configuration that invokes the function. It could be a new file or a message. It could be a lot of things, but we're going to get to that. And there's also the concept of a layer. So when we write code, we work with dependencies, external libraries. A layer is meant to be an easy way of importing libraries. Of course, you can import them individually, but if you import them in a layer, it's usually a set of dependencies. But we're also going to talk a little bit about that in the near future. Okay, so we like this Lambda idea. Let's go with that. Let's make a small POC. We want to create a function. So we actually go to the UI. Let's assume we were in a sandbox account where we can play and try out things. We're instantly asked for a name for our function and the language. Some options are Node or Go, Ruby, Python. We know a little bit more about Python, so we're going to go with that. And then we're taken to this screen where we already see some things that we talked about, like the trigger and the layers. But I want to start focusing on the trigger. Every once in a while, I am going to check the messages here to make sure everyone still hears me. And they're asking me to hide the the sharing option. Is it better now? Okay. Okay. Yes, it's better now. Awesome. So, okay, let's talk about triggers then. Like I said, a lot of things can trigger your function, and AWS actually has a lot of services that can act as triggers. So the first one that I wanted to mention is the simple notification service. So every time something happens in a platform, like a new file arrives in S3, a new notification can be sent, and then a new notification can be created, and then that could act as a trigger. But also there's the SQS, which is a simple queue service. So we could say that every time there is a message in my specific queue, I want that to be a trigger for my Lambda function. You can also use S3 straight away. So every time there's a file in a specific folder in a bucket, I want that to be a trigger. It's really a broad set of options. You can also use CloudWatch logs as triggers, or you can just schedule your function. The list is quite long, and I definitely encourage you to check the documentation. But for this experiment, we're going to focus on SNS as it's the one we used before. So I think it's easier to explain with that, but really the list goes on. Okay, so our function, what do we want it to do? We receive some files in S3, so we want to be able to download a file. We also want to be able to get some relevant information from this file, and then we want to collect metrics from there. So, well, to download a file, I don't want to be the person that adds a lot of code to the slides because I personally never read them. But I thought it was interesting for this case to put some code here just for you to see how easy it is from a Lambda function to download a file. So we created these two small functions, one that gets the relevant file information from an event. If you remember, the concept of event is the data that you're working with in each invocation. So from the first function, you can pretty much get the bucket and the key that together identify where the file is located. So you can return that and then download the file to a temporary location based on this bucket and key information. You can also load the file to memory, I think. And but in this case, we decided to download it to a temporary location using Boto3, which, if I remember correctly, is available by default in Lambda. So no need to import anything. I am gonna check the chat again. 1 second. Okay, nothing new. We're good. Okay, so the second thing we want to do is get relevant information. And for that, I'm going to ask you to assume that our file contains 2 columns. One is a step, and the step would be where the candidate is in their journey. So if they're checking a job description page, that's one step. But then they open an application form, it's another step. And when they apply, we call it application success. So steps. And the second column in our file, let's assume it's a company. And I created the most beautiful company names as an example. But the idea is that given this file, we can produce a dictionary that has, in the first level, the steps, and then on the lower level, companies. And then as a value, you have the number of events in your file that contain that specific step and company. Sounds pretty straightforward, right? We do some grouping, we should be able to achieve this dictionary or this JSON. And then for each of the elements, you can basically do something. And before I say what this do something is, I want to introduce Datadog because I've been focusing on the Lambda part of our experiment. But I do want to talk a little bit about Datadog as it's also part of what we did. If you've never seen this logo, it's basically a platform that wants to make monitoring and alerting easier for you. We've been using that for a while now in Vonk, and it's really helpful. Like, they want to centralize your logs, your traces, your metrics, on the same platform. So you can produce things like custom dashboards with the metrics that you create, or you can use some out-of-the-box integrations. Let's say you have an AWS integration and you start using a new service. It should be really, really simple to already get the metrics from Datadog, from AWS into Datadog, and then have alerts or whatever you want to do with those metrics. You even have some dashboards by default. Yes, but I wanted to make that detour, but basically we're talking about doing something for each element, right? So what is this something? Well, we want to send a metric to Datadog for each element, okay? Yes, so to send a metric, how hard is that? To talk about this, we need to talk about Lambda layers, which we mentioned a little bit in the beginning. But in case you forgot, it's available in the same screen that you see your Lambda code. There's a little button there with the layers. And if you go to add a new layer, which is that set of dependencies, you can select an AWS layer or a custom layer. I think this is related to third party, or you can just specify an ARN, an identifier for your layer, right? And Datadog actually provides a layer to make importing the dependencies easier. So you can just copy and paste the ARN into the UI. Or if you're using something like Terraform, you can also specify it there. So using the layer, you can actually import the Lambda metric function, for example, that does what you would expect it to do, which is to send a metric. So a metric in Datadog has three main concepts, basically. You have a metric name, which defines where you're measuring. So is it a count of events? So you call it event count or something like that. You have a metric value, which is the actual count. And then you have some tags, which are basically extra information that you want to attach to your metric. For example, if you want to create a dashboard for your team, it could be interesting to create a tag that says team, column, and then your team name. And it does need to follow this syntax to work. Or you can add, for example, something like a company ID, and then you put a company ID there because later you want to use this information in the dashboard, for example. Okay, I created my function, I wrote some code. Now what do I do? Well, I hope you will want to test it at this point because that's where we find the problems. And luckily enough, Lambda actually provides some test functionality. And yeah, it's integrated. You can very easily create a new test event. And the interesting thing is that you can use templates. So if you select an SNS template, for example, you will work with an object with the exact same structure that your function is going to receive when it's triggered. So in this GIF, I think I used the S3 template, but it's very similar to SNS. And then for testing, we just need to change the bucket name and the key to something that we have access to. So like still assuming we're on our sandbox account, let's say I go to my bucket that I have access to, I put this my text file.csv in the bucket so I can trigger my function to go to that file and then process it and send the metric. So the whole flow can actually be tested. So we thought that was a pretty interesting feature. And we also wanted to share the CloudWatch logs. Yeah, they do what you expect them to do, which is to show you logs. For our case, you see a bunch of these monitoring log lines because, well, basically because this is another way of sending metrics. If you print something with this format, like monitoring, pipe, timestamp, value, the metric will also be sent to Datadog automatically. We only had to configure the API key. But the idea here is to really show what your options are so you can decide for yourself. And in tests, you usually find problems, right? And for us, the problems were out-of-memory errors. If you've been a developer, you probably saw one of those at some point. And the function invoked multiple times problem. And yeah, let's talk a little bit about each one of these problems. The out-of-memory basically is a problem that we should expect because basically we loaded the content of the file to a dictionary. Of course, it's something that can be improved, but for us, it was solved just by changing some configuration. In the Lambda basic settings, you can actually change the memory values. Of course, you're not going to set it to maximum because even though it sounds great to have more memory, you're also going to pay more for your function, so you don't really want to do that. But you can also configure the timeout options, and in this screen, you can also configure the role. And we didn't talk a lot about the role thing in the WS, but basically your function will be executed not by a user, it will be executed by a role. that needs to have the proper permissions. So in our case, this role will also need to be able to access the file in the proper location. Okay. So we also encountered an issue about function being invoked multiple times. What does that mean? Well, basically in Lambda, I don't know if there is a fix for that, but we understand that there's no guarantee that your function will only be invoked once. So like, yeah, it can be triggered multiple times for the same event. So in the end, what it means for us is that our metrics would be counted twice, and we definitely don't want that, right? So our solution was to actually be creative and work with a different metric type in Datadog. So in Datadog, there are different metrics types, and we started using count because it seemed like the best one to use. But because of this behavior of the functions being invoked multiple times, we actually switched to this gauge one because if for the same timestamp you get two metrics, then only the last one is going to be considered, and that's the behavior we were looking for. Yes. So you wrote your code, you did your testing, you're confident about your function that it's going to be the best function ever. Well, it's time to deploy. And there are some options to deploy. It really depends on your company's preferences. If you want to stay in AWS, there's CloudFormation. There's a service called SAM that I actually haven't used, but I have a little bit of experience with CloudFormation. It's pretty powerful. You can pretty much deploy any resource in AWS with that. It's also possible to use Terraform or serverless. They're also super powerful and interesting tools. It really depends on what your organization usually works with. And if we look at our to-do list, we did some coding, we did some testing, deploy. We're almost getting to the party part. But first, I wanted to show you some results. And let's just see how we're doing with time. Okay, I think we're good. This is the first dashboard that we got. As you can see, it's you can see the number of events over time, and they're split by that step that we talked about. So each color represents a step. I think the most popular one is job description, but I honestly don't remember. And yeah, basically you can play with the time range. So you can see that something happened in somewhere in July with our pipeline. I think I was on a holiday, so I hope someone looked at this. And the second time series I wanted to show is this one, because if you remember, one of the requests from Armand was to be able to have a look at a breakdown per company. So if a company was not sending enough events or something looked odd in the numbers of this company, he could contact them straight away to see if they could fix their snippets. So basically, this is what you can achieve with this set of dashboards. You can select which company you want to check and also a time range. And you could take it a step further and actually create alerts. So let's say a company starts sending 0 events for job description. There's probably something wrong with their snippets. So it would be a nice addition. And something that did happen to us, we thought was interesting, is that we ended up monitoring what helped us monitor. Basically, because there's some metrics available out of the box in AWS for Lambda. So you can see like the number of invocations, the duration, the error count, and so on and so forth. We actually thought the error count was pretty relevant to create an alert from. So we did that. So let's say there's an error with our function, we'll immediately be notified in our Slack channel. So yeah, we were pretty happy with that. I think the last thing I wanted to talk about is the costs, because you might be curious how much this experiment cost. And for all the lambdas that we have in this account, I actually went to the Cost Explorer, and it was actually a few cents in the beginning, and then later don't even see costs. So yeah, I think it makes sense given that it's like 4 or 5 invocations every hour, so it's really not that expensive. So it's definitely recommended if you want to save some money. And some limitations and possible improvements. I would say the way we built this, we have no access to historical metrics. So we would only see the counts of the events after we deploy the function, basically. But it wasn't really a requirement for us to have historical metrics. And if it is something that you do find important, keep that in mind. Unit tests, we actually only did the lambda test that I just showed you, but I think you can also do some unit tests. So definitely encourage you to do some reading about that as well. For our use case, it was like a really simple use case, so we didn't pay a lot of attention to architecture. But if your use case is bigger, please also keep that in mind. For me, that would be all. I did leave some links on the right. I don't know if I can share this presentation on like Discord. It as I put the presentation together, just got some links that I thought could be helpful, like with the metric types, the Datadog Lambda layer, and just a general getting started page. But I am curious about your questions.
Sure. Thank you so much, Natalia. That was a great talk. We learned a lot from it, I think. And it was, applause. Virtual applause, but it counts, right? So,
definitely, yeah.
That was super nice talk. Thank you so much for it.
Yeah, thank you.
There's actually a couple of questions that came in. So I just wanted to ask you straight away, and maybe you can clarify a little bit. So a question that I saw, and by the way, for all the people watching, please feel free to still keep coming in, right? This is live. This is all improv, so we can pick up any comment or question that you have. But the first one that I've seen from Feliz Swaboya, I hope I pronounced that well, is asking, what's kind of the benefit of Datadog over using something like a native solution as CloudWatch, right? So CloudWatch would be kind of the built-in AWS one. You chose, and you talk about Datadog a little bit. What were kind of some of the benefits for you of actually using a tool like this?
Yes. So I don't personally have experience with CloudWatch, so I'm not going to try to compare the two as, because of the lack of information. But I do like, what I do like about Datadog is the ability of playing with the different metrics and building custom dashboards like I showed you. I really like the integrations that they provide. You saw a few, like it quickly connects to Slack, for example. It's just a very powerful tool. We also use something called synthetics that we can basically monitor our services. If something is down, we're quickly alerted. But like I said, I don't know much about CloudWatch, so I don't know if these features are available there as well. But with what I see with Datadog, it's not just a collection of logs and metrics. You can actually build a lot regarding monitoring and alerting as well. So I hope that answers your question.
Awesome. Yeah, I hope it did. And we'll monitor the chat if any other questions come in. There was another related one. Let me just check from El Yakubi Hamza. I hope I also pronounced that well. My apologies if I didn't. This question is a little bit related. Like, was it, did you look at any other solutions actually? So maybe besides Datadog, right? Datadog is one of the vendors. Any experience with other ones, or maybe any ideas, if I can expand a little bit on this question, if you would build this kind of system yourself instead of using a SaaS, do you have any experiences there or any insights?
Yeah, for us, we of course consider what the rest of the company was already doing. For structured logging, I remember seeing Splunk back when I was working with Kublu, but only for logging. So it was very good if you cared a lot about structured logging, but it didn't have, at least I don't remember seeing these additional features with the dashboards and the monitors. So in Coolblue, they actually use Splunk for logging and Datadog for the rest. But we in general, we tried not to deviate too much from what the company is doing, also because we were happy with Datadog for this. But if you have other ideas, please share. I'll be happy to look into them.
Awesome. No, thank you a lot for that insight. So, what I pick up a little bit from that is that, it makes sense a lot also to look at, maybe other teams are using it already. And I could also imagine that maybe, having actually a central solution can make a lot of more sense than, teams having their different solutions as well, right? That's a little bit what I hear a bit from your experience as well. So I think those are great takeaways. If we still have a minute, and I think we are pretty well on time, I had actually another question for you, right? Since you're sharing so much knowledge today. So I was kind of curious, you showed us a lot of examples around, what you can use and how you can think about monitoring and logging. I was curious, like what is actually the process if you're maybe adding a new functionality or a new service, right? So what would be kind of like a little bit the steps that you take if you're adding maybe a new Lambda function or a new SNSQ, like, are there built-in things that you use? Do you need to make your own dashboards in a way? Are there any particular things, that you can use off the shelf or need to develop? Just curious a bit, like what's your approach and what we can learn from your best practices there?
I don't know if this is exactly where you're going with this question, but when we want to introduce a new service, we actually try to build a small POC. For example, we saw a use case to bring a data warehouse to the company. So we made this 2-week POC to evaluate some options, see the cost as well. We ended up going with Snowflake as a data warehouse for the company instead of Redshift, which was available in AWS, but it didn't have things like the JSON support that we were looking for. And the pricing model was a little bit different. So we try to do small experiments when we want to bring something new. But in general, I think it's also good practice if you're building something new, you also want to know beforehand what you want to monitor. So you put that as a requirement as well to do monitoring and do testing. I think these are good practices to keep in mind. Did I answer your question?
I think you did, right? So I put you a little bit on the spot just with a question, but I'm also hearing from you. Actually, I think the good advice here to kind of try these things out, right? In a 2-week sprint, maybe, as you were saying as well. And I can kind of see personally how maybe trying and actually time boxing something like that will give you maybe more input as well than reading documentation or listening to sales pitches. So that sounds like a good approach, actually. So thanks for that.
Yeah, no problem. But please also read the documentation.
Oh yeah, sure. Not saying you should skip it, but yeah. Awesome. Yeah, thank you so much. I see also that Feliswa and everyone who asked the question is happy with their answers. So don't think we have any other ones. So I was thinking, Leon, if we're going to do a break in a minute, right? I believe.
Yes. We have a break planned until 7:20. And I think that makes sense because that's the time we communicated to people. So if they want to join in later for the second talk, which will be by Zamira, and she will talk about how to build and deploy EKS across AWS accounts. So in case they want to tune in later just to see that talk, we should start on time with that. So we have time for a break.
Awesome. Yeah, I see that Natalia already disappeared, but still wanted to thank you. You probably can still hear us. Thank you a lot for the. There you are. Thank you a lot for the speech. It was great. Also great discussion and questions. So I see also thanks from Mark Duiker right now, one of the co-organizers. So thanks a lot, and hope to see many more of your speeches. And you also at the meetup here. So
thank you guys
for a great speech. Thank you.
Yeah. Thank you.
Bye. Thanks.
So well, before the break, I just wanted to also throw in really quickly that you can join us on Discord, and that's where we will have our party game session after the conference, which is something that conference meetup event, which is something that we're trying to just like have a little bit more interaction for these events. So don't go away after. Don't just throw away all your plans that you have for tonight. This is going to be awesome. Hi, everyone. Marek, you look surprised.
Yeah, sorry, no, I lost track of time, but indeed, it's time. It's time for the next speaker.
Exactly. Hope you all had a good break. You did what you needed to do. So we are now ready to welcome our next speaker, who's Zamira. She is a solutions architect at Mobiquity. And she's there. And hi, welcome.
Hi, everyone. Hi, everyone.
Hey.
Hey,
Zamira, would you like to introduce yourself?
Yes, also I have a slide I can introduce myself, but if you want to introduce me, it's okay for me as well.
No, it's totally fine. You do you. I always think that it's best if the person who knows the person best should introduce them.
I have maybe one small question. So I'm looking at the back of your screen. I see something that says hero there. So maybe you could tell us what that actually is.
Smooth.
Not everyone has that, I think. So.
Well, this is not. So I mean, a hero is more, let's say, organized by AWS, and there are people that basically do a lot of organize a lot of meetups, events, and write a lot of blogs. Also, are skilled in AWS. This is why some people are recognized by AWS itself. So I'm really happy to have this and be one of these people.
Yeah, so sorry to put you on the spot. I just figured, I know that you, and we've known each other for quite a while, right? So I know that you're also super active with a couple of other meetups, the AWS meetup in The Hague, and I've seen you in Amsterdam as well, and at conferences. And I believe you're also, actually, both of us are also in the AWS Community Day, right? Where I think the agenda just went out today. So, super happy to have you here today for this meetup, also the serverless one. But yeah, I know that you're a well-recognized AWS hero as well, and also people can see you very often at other meetups. And yeah, as actually someone also in the comments is mentioning, you're even still connected, I think, to the Albania user group, right? Are you still doing that as well?
Yes, I do.
So you're really all over the place. That's awesome.
Yeah, thank you. Thank you so much, Marek.
All right. Hey, let's should we
I think Marek introduced you already.
Enough awkwardness now, so we can maybe let you speak if that's okay.
Yeah. Okay.
So
awesome. Hey, have fun, enjoy, and we'll connect with you after for a little bit of Q&A as well.
Okay, let me share my screen. Okay, can you see my screen, first of all? Okay, so first of all, I want really to thank you, Marek, thank you, Sarah, thank you all that you invite me today. I'm really happy to be here today to share some topic about the technology. And today I will talk about AWS EKS. Probably most of you are familiar, probably not. However, I'm going deeply to explain what is this AWS EKS and how we can deploy across environments. Marek already did some introduction for me. However, I wanted just to add that I'm solution architect with more than 7 years experience designing and implementing critical and complex solution in AWS with data analytics, computing, serverless, machine learning for small and enterprise company. Only last year I joined Mobiquity, when my main responsibility is to help customers with their digital transformation, also to design the good solution that fits with their requirements. We are also organizing a lot of meetups in Netherlands, in Albania, and here in Netherlands. And I'm organizing AWS community here in Netherlands. So thank you so much again, Marek, that you mentioned. I want you to invite every one of you that be part of this event, because they're a really, really nice speaker, and especially we have the keynote, Wernel Vogel, that is the CDO of AWS. I think it will be very, very fun. And if you want to know more about me, definitely you can find me on social and Medium, that I have written a lot of blogs about AWS. So that's, I think, is enough about me. So let's get started directly with the presentation. I want to divide this presentation today about, let's say, three main topics. The first one, I want to talk about EKS Fargate and EKS Managed Node. What is the difference? How the AWS approach about this solution. The second phase of this presentation, I want to show you the language that we are going to use, how we can create this cluster, what kind of language we are going to use. There are so many ways that you can create the infrastructure. However, today I want to show you the CDK. And the third phase, not less important, I want to show you how we can implement EKS cross environment, how we can deploy. To start with the first one, EKS versus managed node. Containers really are not new new technology. They have been on the market for a long time, and most of you probably are really familiar what containers are, how Kubernetes work. However, different companies and different providers, they have different way of strategies, different model, how they implement Kubernetes and their provider. AWS also had two models on two strategies that how they want to implement Kubernetes in AWS. The first one is EKS Fargate. So this solution is completely managed by AWS. That's mean you don't really need to have a worker node, or you don't need to have virtual meshing to manage scalability, to manage fault tolerance, to manage patching, but the engineers or DevOps can focus only on their workloads, and this is really, really nice. And the second model that AWS provides you is managed nodes. That means this is fully responsible by customers. Customers can take about scalability, can take about how they can have a patching and all of this other infrastructure, not only the workload part. So it's AWS give you a flexibility on how you can approach with Kubernetes. So depend on your case, depend on your requirement, you can choose which one is your favorite. I want to start with this design to explain some different components, and I want to focus especially in four of them. The first one is security, the second one is scalability, networking, and the cost. Let's start with the first one, security. You know, it's so important to have in place some good solution how to protect the data and the system for challenging threats. So as you see here in this design, there are two main, let's say, colors. The gray color says that is mostly the customer responsibility, and the yellow color is AWS responsibility. So when we talk about security, it's always a good start to start with who has this responsibility, what I am responsible to secure. And when it's come to this solution, as you see, Fargate, as I mentioned before in the previous slide as well, is more fully managed by AWS. So you don't take care about the infrastructure. Definitely is managed by AWS. But when it comes to manage node, you have to manage the worker. You have to manage the instances and all how you put the security on these instances. Let's start with the first one, identity and access management, that are both responsibility of the customers. So it doesn't really matter which cluster you choose to create on AWS. So both, so identity access management definitely is you take care of the users, you take care of how you create the roles, how you put the permission to these roles. the good recommendation is definitely not to put the stars on the policy, but to have the right permission that this cluster need to have. So authentication and authorization are quite important when you set up a cluster. In AWS, you have to put the right users and the right permission to access the management of Kubernetes. And also see that is cluster role. This is quite different. It's not connected to let's say config mapping, but this role is directly when you set up a cluster. And this means, so what kind of permission can have this cluster in AWS? Also, you see another role here that is node role or provider roles. This means the first one, when you set up AWS managed node, automatically you have to create YAML roles that are related to EC2 instance, and you have to manage the policy. What can do this instance? So, for example, if let's say you have all the pods and you want to access S3 bucket, so in the IAM role, you have to put the policy to access S3 bucket and a specific endpoint of the S3 bucket. And from other side is profile role. So in case you want to have a fully managed service by AWS, so when you create a profile that is attached to the Fargate cluster, you also have this role that, let's say, is connected directly to the pods, or to this worker. You don't see worker because the worker are always there, but in that case are managed by AWS. You only have the possibility to manage the access and the permission to the roles. You can also use OpenID Connect, so is definitely in your choice, is alternative to how to access the management, the profile of the cluster. And there's other security as well that need to take in consideration is pod security, is when you restrict the container that can run as privileged. So you don't run a processing container as a root. Remember always that. So don't run a root. Restrict the use of the host path. Set some requests as limit of each container to avoid resources containing as DDoS attacks, etc., etc. The third one that I want to mention about security is detective control. So always make sure that when you set up a cluster, it doesn't matter which cluster it is, you have to have in place some audits, logging, and you want to collect, for example, login. Natalia mentioned before CloudWatch, but also you can have third-party tools as well. So there are so many tools that you can analyze, and you can do operation. Probably you can do data analytics using the data to collect these logs as well. So there are so many solutions. Important is to have always enable auditing logs. Probably you can have CloudTrail as well to provide some action to this cluster. You have to have always network security in place. So I'm staying a bit longer to this slide because I want really to show you all the possibility about the differences, let's say, between these two clusters. Also, network is very important. How you set up the security groups, how you set up the ACL, and are fully responsibility of the customers. But there is something else as well about networking. So as you see in this design is custom VPC, where is hosted basically customer manager, where is hosted the management control of Kubernetes. This is fully managed by AWS, so you don't take care about that. Is let's say manage how is hosted, ETSD, control panel, all of this stuff. AWS has internal networking that manage from the ASR. What you have to take care is only the VPC when this cluster and the pods or the nodes in case of managed nodes are hosted. Infrastructure as well is important to use always OS optimized, that is to have infrastructure immutable. And if you can, always you can run Amazon Inspector to access host for vulnerability and other things as well. And the last one should be image security and data encryption. So make sure always to have in place small images with use multi-stage builds, scan image. AWS has a really nice string that you can scan the images when you put, for example, an ECR. There are some way that you can scan for vulnerability on all of this stuff, and use always encryption. This is all about security. For scalability, as I mentioned before as well, that all this is connected to responsibility in EKS, node managed. Scalability of the nodes is fully managed by the customer. So you have to take care how you can set up the policy. So you can have probably different kind of strategies, how you can scale up and down the container. You can have vertical or horizontal scaling. This depends definitely by your workloads, and depends on the CPU, depends on the memory of the instances. Important is that you have to have always this strategy to make sure that in the end your activity are running, is no interruption, and the end user are seeing the website as is expected. From the other side, the EKS Fargate, scalability of the containers, scalability of the work nodes, of the pods is fully managed by AWS. So now let's see networking. As I said, so I want to share with you 4 important components: security, networking, scalability, and cost. I wanted really to share this experience with you because I had some issue during my experience. This because we didn't really know how our workload it will be in the future. So why I'm telling that? It's so important when you set up a cluster in AWS, you have to know how it will be your workload, how many pods you have to have in the future. Because if you do some limitation in the beginning and you create a network that is very small, but you may have so many pods in the future, you could not be able that this node can be spin up because there is no availability EP. So I have an example here to show you. For example, if you have a restriction of the subnets when you are going to host the cluster /25, the maximum of IP availability you can have 125. And in case you want to have, for example, you want to have MF5 large instance, that this is only in case of managed node, because in Fargate is fully managed by AWS. You really don't take care about this. AWS the containers and the pods up and down, and the network in this case is managed by AWS. But in case of managed node, it's really important. So, as I said, for this instance, maximum internal and you can have is only 3. And the secondary, you can have only 9. So maximum is 27 pods. So this means at the /25, it's a really good approach. So you can have this without problem. But in case you want to have an instance, this /25 subnets, but you want to go to start with a larger instance type, because probably you will have a workload that a lot of traffic in your infrastructure, you will see that maximum of the bot is 232 pods available. But if you choose the subnet /25, it's not going never to go to 232 because the limitation of the subnets. That's mean the maximum that you can have here only 125. So it's not possible to go even you choose the larger instance. So here is another example as well. Let's say we have we have a cluster that are with 5 nodes, and each nodes have 40 pods disponible that are up and running in the instance, and the maximum is 200 IP addresses. And with 200 IP addresses, a good approach probably could fit /24. And another case is probably you will have 30 nodes in the cluster, and each node will have 50 pods. In this case is 150 IP addresses, so the good fit would be /21. You know, I am working with enterprise companies now, and especially with finance company, and for them it's so important to have the networking as small as possible. But at the same time, they have really big traffic, and they have complex solution. So it's quite challenging to find, let's say, a good approach to fit their requirement. What about the cost? Also, the cost is very important, and we want to know how much will cost the solution in the end. What are the differences between Node Manage, Worked Manage, and EKS Fargate? They have the same price, or Fargate will be cost less or more? Let's see. Let's say we have the case 1. I have 50 nodes, so this is the first case when we choose to have managed node using, for example, 2 VPC, 16 gigabyte memory, only for 3 hours. So the first case, my price is going to be around $14 for months. So this is the price that I choose in Ireland. Probably for most of you that you don't know how the price works, EC2 instance, the virtual machine in AWS, you pay on demand for hours. So this is the price for hours in Ireland, but different region has a different prices. So this is only for 3 hours, for 30 days. For 15 instances, I will pay only $14. And in case I will have the same instance but running 24 hours, because probably I have production here, and the price, it will be different, so $119 per month. Now let's see the case of Fargate. What happened with Fargate? So I will have a different price. So how is calculated, let's say, the price in Fargate is a bit different. It's not, so we don't have a worker node, we don't have virtual machine here. So it's calculated, let's say, only 2 things. The first one is the CPU charger, and the second one is memory charger. So the first one is the CPU is calculated the number of pods, for number of the CPU, for price, for CPU seconds, for CPU duration, for day in seconds, and the memory is calculated in number of pods, for memory in gigabyte, for price for gigabyte, for day and for seconds. So let's see the second case. Let's say we have the same number of pods. We have 15 pods using 2 VPC. 16 gigabyte of memory, 3 hours and 24 hours. For 3 hours, we will have a price of $129 per month, only for the VPC, and for memory, we will have $48 per month. What's happened for 24 hours? So we will have full day. As I said, we can have production running on Fargate. The price, it will be really surprising, really high. And for example, in the first case, in 3 hours, it will be around for 3 hours, it will be around 43. Maybe I will have an. Oh, sorry. Yes, in the beginning is for 24 hours, and the second example is for 3 hours. So for 24 hours, it will be like $40,037, and the second one, it will be 192. So let's see this graphic now, and you will see for a long period how the price is going to change. So we will start probably with the same price. As I said, in two cases, we have managed node and we have Fargates. You see that as long as we go and more we use Fargates, or probably especially when we have 24 hours running Fargates pod, the price is going to be very, very high, and we probably go in more than 3,000 euros for 6 months. So this is the how looks the price for short term and for long term. For if you want to run the instance for 3 hours or probably 24 hours. So my recommendation is, my suggestion is, if you want to run, if you have something only for test, definitely you can go for pods because it doesn't cost too much. But if you have something that run 24 hours using a Fargate, it will be to cost too much. But definitely this depends on the case, because if you don't want to manage anything, because maybe you don't have enough resources in your company, or maybe you don't have good knowledge, enough knowledge to do that, so you can go with a full managed AWS service, and you can go with that without take care about the cost. However, this is the good overview of the pricing. And now I will show you the second phase. We saw already some differences between EKS Fargate and EKS cluster, a classic cluster managed node. So how I can create this pod cluster? There are too many ways that you can create. So around there are probably Terraform, is CloudFormation, different language that you can use. I prefer to use CDK because there are some good inputs of using that. But you can use what is in your preference and what is a requirement by your company. CDK, because this gives you a possibility to choose, first of all, your favorite language. In my experience so far, I have changed a lot of tools, and always I have to learn new tools. Always I have to learn new language to implement the infrastructure. I have to learn CloudFormation. I have to learn Terraform, or probably Python, JavaScript, so many. And if you ask me today, I am not expert in one of them. So because you really can't learn everything in the live. CDK give you the possibility to choose a language that you prefer. So you can, for example, if you want to implement infrastructure and you can choose only Python or JavaScript or TypeScript, you can go with that without taking care to learn a new language. So let's get started. What I really like to this as well is that CDK give you is really high level language. If you don't specify resources, or if you don't specify something, AWS or this API automatically create the resources for you. It's really high level language. For example, in this case, I want to create a node manager and Fargate cluster. As you see in this image, if I don't create networking, AWS create networking for me. So I don't really care. I don't have knowledge in networking. I don't know how many layers I have to create. You can go only specify the cluster, and networking is spinning up with you. You can have a layer, private layer, public layer when you can host your instances. The same is for roles. So if you don't specify in the language, AWS is going to create for you. Only when we talk about security rules and authentication config maps in Kubernetes, this definitely is responsible by you. That's mean if you don't specify, AWS don't create this for you, because if you remember, I shared in the beginning of this presentation who is responsible for what. So in this case, AWS is not responsible for that. It's completely, you have to manage that. Here I have an example on how you can start with CDK. So as I said, I'm a bit familiar with Python, but you can choose your favorite language. You can initialize a project just using CDK init app and your favorite language. You can use CDK sync when you want to see in your local computer what I have to create or what I have changed it before going to deploy. CDK deploy, just deploy your infrastructure on AWS. CDK diff give you differences between what you have in your local and what you're going to, what is deployed already on AWS. And definitely when you're going to destroy with CDK destroy, as many other tools and platforms has the same logic mainly. In this slide also you see that is networking. As you see here, there are only some lines to create a networking. Probably if you know already CloudFormation, so it's really long template, probably thousands of lines only to create a networking. So you really don't need that. You specify first your constructor, and you create your first module of networking. So in this case, you specify the name, the range of the VPC, and only specify .public, EC2.subnet type .public. In this case, AWS or CDK API is going to create you internet gateway, is going to create you all the configuration root table, so you don't need really to specify this. And other case, subnet type .private. In this case, AWS is going to create you not only the subnets in private layer, but also NAT gateway that are connected with a private root table, etc., etc. So this is why I said it's really high level. Now let's see two clusters. So what is the differences between them when you create both of these clusters in AWS using CDK? So the first layer, you just import the packages that you want to create. In this case, it's EC2 EKS IAM roles, and you specify the constructor. You initialize the constructor of the stacks. And the second phase is when you have to, let's say, set up the cluster. So you can set up the name, the roles, what kind of roles is, and it's quite equal. As you see, there is no too many differences. What is the differences? Let's see. So when you specify now the nodes or the profile, in case of cluster EKS manage, you have to specify the instance type. And this is very important to remember. This, you have to always be connected with networking. And you have to be also connected with your workload. How many pods? So it's very important to choose the instance type based on your requirement, so to fit well in your infrastructure. And you can specify also the subnet. So in case of managed node, AWS gives you the possibility to put the cluster in private or in a public subnet. But from the other side, in Fargate, AWS don't give you this possibility. So you have to create the cluster only in private. So because we don't have worker node in this case, we have only the pods. And the pods are, so only this, the role that you are going here is directly connected to the pods. This is the difference that you see. So now we saw already how we can create, let's say, the both cluster. Now let's see how we can implement. So there are so many ways you can implement infrastructure on AWS. You can do it manually from your computer, but this is not, let's say, the case. You can have a different pipeline approach on how you can build and implement the infrastructure. So I wanted to show you some best practices on how to approach to have a good, let's say, solution or good workflow, how to deploy Kubernetes on AWS. First of all, let's say the pipeline for me are set of operation collecting of practices that enable application development teams to deliver code changes more frequently. And this is very important. Why more frequently? Before I joined Mobiquity, I was working in a software company, in a product company, and they do the change, they deploy every 3 or 4 months. And I think this was not really good solution. It has so many problems, because you can imagine this situation. Developer work for 3 months, and for 3 months they are going to deploy. After 3 months, they are going to deploy live this new feature or new bugs. And after 3 months, they realize, oh well, there is something wrong here. It's not as we expected to do, so we have to change. And they are going back after, so probably more than 3 months to understand where they can fix their code. It's like you are having probably most developers know when they have to let's say to do troubleshooting in one page and want to do troubleshooting in just one line. It's more easy when you have a small pieces to do troubleshooting and to do deploy more. This is why very important, don't do deployment monthly or probably yearly, but do it very often, and weekly, probably daily if it's possible. But sometimes depend definitely on the case, because sometimes enterprise companies has some approach, some compliance, they go in longer than expected. Also, decrease lead time. This is important as well. This comes from my experience. I'm working with a client that is in South Africa, and they have all the, let's say, AWS complete solution, all the managed solution on AWS, but in the same time, they have some services that are in on-premise in South Africa. What's happening? During the testing, let's say, testing process, testing phase in CI/CD, all of these services that are in AWS need to connect in South Africa and come back in AWS, finish all the tests. There's a lot of latency, and the time to build and deploy really take long. So I will say, make sure to have a good approach and good strategy, that all the services are well connected together. Also, they are in the same place. So basically, the lead time is when you start to build and the time that you finish to deploy in production. And the latest one is decrease always the failure rate is important as well. You have to make sure that so to measure, let's say, how often you are going to deploy a deployment failure, especially occurring in production, what kind of strategy do we have for deployment, and how often cause issue in production, how often you need to roll back, then you have to change. So always is good to decrease the failure, because when you have a small failure, you can easily redeploy again, and you can troubleshoot very fast. So when it comes to pipelines, you may have a different approach. You may have different tools to have a full workflow of building and deployment process. However, I would say there are 4 important stages: source code management, to have a good Git flow strategy, Git branching strategy. The building phase is so important as well. When you build a package and you create a package before testing. And testing, when you will have probably integration tests, security tests, and other tests as well, this package is ready to go in production. So I'm not going to focus too much on this slide. So basically, some differences between continuous delivery and continuous deployment. You may know that continuous delivery is, let's say, is the same as deployment, but only with difference. There are some manual improvement. So in enterprise companies, for compliance, for maybe because they don't have enough resources, or they don't have enough tools, or maybe the right tools, they want to have always improvement before going into production. They want really to make sure that this software work as it should. So this is why sometimes the company prefer to have continuous delivery. But always is another approach, continuous deployment, where it's full automatically, so there's no human intervention. You have to do quick release, and this is especially adapted, let's say, by startups or small companies. So you don't need to do improvement manually, but the tools or the systems are doing for you. And this is how we can build and deploy CDK or the cluster across AWS accounts. So this is, let's say, a fully managed AWS solution. You will have code commit as source management code. When you could have Git flow strategy here and Git branching strategy. Code pipeline is basically the service that allow you to manage all the stages and all the steps. Code build. This service I have used to build, let's say, the packages. I didn't mention before, when you use CDKs give you in output a CloudFormation template, and this is the package before to deploy the infrastructure. So code build right now, from the name, it's not really good, let's say, to use for deployment, but I will say this is limitation on AWS right now. It's no service that you can deploy CDK directly with Kubernetes. So I hope they will do something. Probably I will ask Marek for this if they have any use. They have really good approach with code deployed with ECS, but they don't have right now, I would say, with Kubernetes, to deploy Kubernetes or to deploy application on Kubernetes. So this is why I used here code build. And as you see, I'm going to build first infrastructure in dev account, and later in UAT sit account, or you can call it whatever you want, the environment. And once here is everything as it should, the quality, do all the tests, we can deploy in production. So this is how it works in general. And I think I finished with that, but before I will close, I don't know if I have time. I wanted to show you. I wanted to show you just one moment in source code as well. So I didn't publish yet this project. I just created. I have another monitor here, so I'm sorry if I'm going back to this one. I wanted just to show you here the code here, example on how I'm going to create the CDK using CI/CD, so using the pipeline, but definitely with CDK. So how are I going to create these clusters? I have, in the first phase, he's creating ECR repository when I'm going to put the images. For example, if you want to deploy any pods or application. In the second phase, here are the roles of the pipelines. So what kind of permission should this pipeline have? You see here there are stars is only for test this project. So it's not for production. Don't take care in consideration this part here. And And later we have also the roles of the code build. As you see here, so I'm just specifying the principal, what kind of permission. This is wrong, but this is only for test. And I have the projects here. I have the when I'm going to deploy this CDK first. As you see here, in the first stage of the pipeline, I'm going to deploy in dev account, and I'm going to specify all environment, and as you see here, what kind of CDK version I will start, what kind of EKS instance type, cluster type. This means I'm going to deploy Fargate, or I'm going to deploy a managed service. In which account I'm going to deploy this. So I may have so many accounts, in which region as well. So I can deploy this environment in cross region and cross account. And here is which environment is important. So I have here different stages. I have UAT stages. This means this is going to deploy in UAT, and in the end I will have production as well. So this is going to build and to deploy the infrastructure in production. I wanted just to show you in this project as well how you can build it manually, or how you can build it from your local computer. You can use Dockerfile as well, just run in your computer, and you can test it before going to the pipeline. And in the same time, I wanted to show you how you can deploy in pipeline. So as I explained it before, these are the scripts that you can run in pipeline. So what is the AWS accounts, code build, role, name, and for example, you're going to create first networking, and later just create, for example, a node manager, or probably a Fargate. And in case, for example, I want to deploy an application as well, I will have the logic that in the first AWS code build, I will apply a network. In the second phase, I will apply ECS Fargate, and in the third phase, I will apply an application. So this is the case when I'm going to apply application. This project is not available on GitHub right now. As soon as I will publish, probably I will let know from my social. So maybe it will be useful on how to build and deploy across AWS accounts, both Fargate and the cluster. So I think this is all of my presentation. I hope you learned something new or you enjoy. So thank you really so much. Thank you, Marek. Thank you, Sarah. Thank you to everyone for really good organization.
Great. Thank you so much, Samira.
Thanks for your talk.
Thanks a lot.
Yeah, thanks. We learned definitely quite a things. We don't have that many people speaking here about EKS, right? It's a little bit going into the dragon's den, serverless meetup. But it was actually, I think that's, thanks a lot for the talk. It's always super refreshing, I think, to also have a bit something outside of our comfort zone, right? So we talk Lambda all the time, but to actually learn a little bit about containers and also CDK actually was really good, I think. There were a couple of questions and a couple of discussions actually that we were having. So wanted to, also pick your brain a bit as someone who's, worked with EKS and a couple of other services as well. So I'll ask a little bit kind of the classical question first. When to use containers, when to use Kubernetes? What's a little bit your take on it? There's, of course, a lot of reasons you can choose, but maybe from, your professional experience and what you see with customers, what are kind of the reasons why you should go with EKS or maybe with Lambda?
Thank you, Marek. This is really good question. So definitely depend on the case. depend on the situation, the requirement of the client. So sometimes it's not the right solution or the right tools for a specific project. But definitely, if you have, let's say, if you don't want to take care about infrastructure in general, and you want to go fully serverless solution, you can go with Lambda function. So because Lambda function is fully managed by AWS, so you don't take care about all of this stuff, patching or probably instance operation things. So go for Lambda function. In case you have workload, a lot of traffic that are in your infrastructure, really complex solution, maybe the good approach is to go for containers, because and if you want to have more security in place, you can just go with that. Yeah, because especially with enterprise companies, they want to have some compliance in place, and they want to manage by themselves, let's say, all of this. So
all right, awesome.
Yeah. Thanks, that makes a lot of sense.
Cool. Just checking. Thanks a lot for that answer. Just checking. There was just a question from Edmund also coming in.
Yeah.
And the question is, as the example you showed, it looks really easy to go into production. From your experience as well, is it really that easy to go into production, right? So I think what Edmund is maybe asking here, you made it sound easy, as if there were, no issues whatsoever. But were there any learnings, any problems, any, what's sometimes called paper cuts that you had actually doing that? I think that's a little bit what they're looking for info for.
No, it's not easy to go in production. So definitely depend on the case. So if it's not really complex solution, and probably is really small, let's say it's not critical solution, it's very easy to go in production. You may have probably, as I say, deployment, fully automated deployment, and you can just set up some tools and just go in production. But when you have the situation, when you have a really critical data and complex solution, especially across accounts, across services, or probably cross the provider as well, it's a bit challenging, because there are so many things that you have to integrate, and so many services, security in place, networking in place, scalability. So yeah, depend on I would say on how much complex is the architecture, or how much complex is the solution in total.
Mm-hmm. Awesome, thanks for that. And does that mean with EKS, maybe you could share a bit? It's more my personal question, not one from the audience. Like, how does that then work with SREs, for example, or kind of like how do you, remember again, I'm a serverless person, right? So I've been kind of on the serverless side very much for the last 5 years. But just curious a little bit, what are maybe some learnings or some best practices also with SRE, or kind of like the, managing this after you go live? So building a bit on the question of Edmund.
Kubernetes in general offer you very user interface, let's say, that probably for most of people is more comfortable to use, like, for example, serverless or command line or Lambda, that you don't have any interface, you manage all of these workloads. Kubernetes, from the other side, you will have this interface graphic, when you can manage really easy all the pods, application, and you can show Kubernetes shows you how the traffic is going up and down across the pods, and the security as well. So this is, I would say, that the differences. But if you are like a guy that you prefer only command line, sometimes Lambda is the best option.
Right. Yeah, no, I see what you mean. It's an interesting angle, kind of like how you program it, how you build it.
Yeah.
What I guess you're referring to, and that's probably as much as I know about Kubernetes, is things like kubectl or kubectl and some of the APIs, like those are, have some, you can see that as a benefit that you have kind of like a more uniform way to get in. Awesome. Yeah. Thank you so much for that.
Thank you so much.
Thanks so much.
Thank you.
And with that, we are at the end of the event. And thank you so much for joining us tonight. This was our first meetup since the break, and we will be back in a month, so first Wednesday of the month. And thanks so much to Sarah for doing the tech, and also for Stace, who's been working behind the scenes to monitor our channels for questions. And thank you very much, Stacy. And yeah, join us on our Discord server, because we're going to have a little hangout. We're going to use the video chat feature there, and we're going to play a small round of party games. So any last words from you, Marek and Sarah?
I would say.
Sorry, you go.
Yeah, thanks so much for tuning in. Again, as a small gentle reminder, always looking for speakers. So ping us on Discord, send us an email, or tweet us. I think we accept all of that. And looking forward to also have local, international speakers, first-time speakers, maybe more experienced speakers. Everything is welcome. As long as it has something to do a bit with serverless, we'd love to have you in the meetup as well. So thanks for joining in. Sarah, anything from your side?
Oh, no, I just want to say thank you to the speakers, Natalia and Zamira. Really, thanks a lot for joining us today. And we look forward to the next one. All right.
Yay. Goodbye. See ya.
Bye.
Goodbye.
Bye-bye.
See you.